Hey, how is everybody doing? This is Mr. Gable, and we're going to try our first math lesson. So here are the things that you're going to need for today: your iPad, a pencil, your math journal, that's the green, and your math notebook. If you don't have your math journal, I've posted these pictures or this PDF, your journal pages, in Schoology. So, all right, let's get going. So when you see this icon, add to notebook, that's what we would be taking as notes. I just thought I'd put that down there in case I forget to say it, since you guys aren't live to remind me, hey, should we be writing this down? So if you see this symbol, you should be drawing the images and the definitions for certain. And there's going to be a lot of that today. So be ready to go. And remember, this is a video. You can pause it. All right. So our notebook title for today is Angles and Triangles. We'll be using this for the next probably 4 lessons or so. And our learning target is today you'll have a better understanding of angles within parallel lines cut by a transversal. Oh my golly, I don't know any of those words. Cool. Well, that's why we're here. We're going to do a little learning. So let's start with parallel lines. I crossed that out just to be funny because my thing said in the classroom. So if you could try to find some examples of parallel lines around your house, and let me give you my example first. So when I think of parallel lines, I think of railroad tracks. I think of the lines down the center of the road, or the edges of the door, top, bottom, or left to right. So where the red lines are, that's the parallel lines that I see. You'll also see that we have our add to notebook. So what does parallel mean? If they're always the same distance apart, we call them equidistant. They'll never meet their parallel lines. So pause the video and see if you can find some parallel lines around your house. All right. So the next thing we want to do is we want to just do a quick review of proportions. So when we did ratios and proportions, we saw problems like this. And when we have problems like this, we need to cross multiply to make them better. So let me do the first one with you, the 16 over 3. So 16 over 3, x over 9, we're going to solve for x. And my red lines there are to cross multiply. So we're going to get, when we cross multiply, 3 times x is 3x. 16 times 9 gives me 144. Divide both sides by 3. And then I'm going to get x equaling 48. All right, let's have you pause the video again and do the other 5. All right, let's check your work. So here they are. So we had 48 for that first one. And you can go ahead and pause this again and check your work. I won't go through those answers on the video. All right. So if you know the measure of one of the angles formed by 2 parallel lines and a transversal, you can find the measure of all the other angles without using a protractor. Why or why not? Well, that's a big question, and there's some big answers to that, and that's what we're going to spend our time with. So that really gets at our learning target. Why are we, how can we break this down? How can we solve that? If we know one angle, how can we solve for all of these angles? Okay, because right now, this transversal here, cutting the 2 parallel lines, and we know those are parallel lines because we see that little arrow there and that arrow there. And then this is a line because it has that arrow going each way, meaning that that line goes on forever. That's called the transversal. All right. So we're going to be using this. We don't need a protractor. Don't get that out. I know some of you have talked about that in class. Why don't we just measure? We don't need to measure. We can prove it with mathematics, and it's more accurate. All right. So let's put this in our notebook, both the picture and the definition. Transversal is a line intersecting a system of lines. So this is the transversal. When you draw that picture, make sure you label the transversal. Go ahead and pause the video and add that to your notebook, and when you're ready, hit play again. Okay, so let's see if we can do this. Let's identify the parallel lines. Okay, and identifying the transversal. So what I want you to do right now is I want you to add this drawing here to our screen. Okay, and that drawing or to your screen, excuse me, to your notebook, and then we're going to talk about those questions. So go ahead and pause again, and then when you have that added to your notebook, then go ahead and hit play. Okay, so identifying the parallel lines. The parallel lines are K and L, as it says over here, and I know that because this little arrow here, down here by the K, and this little arrow here, it tells me that those two are parallel to each other. They will never touch, they will never get any closer together, any farther apart. They will remain on that line forever. The transversal is cutting the two parallel lines, so that is our M, line M. And then how many angles are formed when we do that? We have 8 of them. So 1, 2, 3, 4, 5, 6, 7, 8. All right. And then which angles are congruent? Now congruent, we've used that word just kind of a little bit, and I've got a slide for that coming up, but congruent is a nice word to say that they're equal to each other. So congruent means equal to. Okay, or similar. No, not similar, excuse me, equal to. So which ones are congruent? Which angles are congruent? So angle 1 and angle 3 are congruent, and 1 and 6 are congruent, and 3 and 8. And they're congruent because that's what's called a vertical line. So that also means the opposite of that is true, that 2 and 5 and 4 and 7. They're also congruent angles to each other. So 1, 3, 6, 8 are congruent, all the same measure, and 2, 4, 5, and 7 are all the same measure. So now think about that. If we knew just 1 or 2 of those angles, we would their degree of measure, we would know all of them. And we're going to show you how to do that. And this is kind of really cool, and I think it's also really important. This is one of our big units, and I'm sad we're not together for this because I really love this unit of math as well as the others that we've done too. All right, so go ahead and add this figure to your notebook and then hit play when you're ready to go on. But we're going to use that figure to find the measure of angles 1 and 2. Okay, and note that over here we have angle 110. So that's all we have, but we're going to use that 110 to be able to say, how do we find angle 1 and 2? So have this drawing in your notebook and get ready to add some more. Okay, so angle 1 and the 110 degree angle, they are what are called corresponding angles. Okay, they are congruent. Okay, corresponding and congruent. Corresponding means that they're the same measure. Congruent means that they're equal to one another. So angle 1 is 110, and then we already have the other 110 degree measure there. So that's congruent. And as I said, we'll take a note on congruent in just a minute. So that means that angles 1 and 2 are supplementary. Now supplementary means that they add to 180 degrees. And I've got a slide on that in just a second too, so don't write that down just yet. But that means that if I said angle 1 plus angle 2, they're going to equal 180 degrees. Okay, that's the definition of supplementary, that they equal 180 degrees. So 110 is angle 1 plus angle 2 is equal to 180. Now think of this like an algebra problem. Okay, now I'm going to say, hey, I'm going to subtract angle 2 from each side. Okay, and so that I'm going to subtract that 110 from each side. Sorry, I misspoke there. And then, so the measure of angle 2 then is 70. And angle 2 has to be 70 because angles 1 and 2 together form that straight angle or 180 degrees. Okay, a lot of terms there. You can always pause, you can always re-listen to this, but I'm going to move on to the next slide. So here's that corresponding angles. The angles which occupy the same relative position at each intersection where a straight line crosses two others. If two lines are parallel, the corresponding angles are equal. So here we have this angle here is corresponding to that angle. If we go back, that's the same thing as this. The 110 was corresponding to that angle 1, and so they're also 110. Okay, so pause that, make sure you get corresponding angles, the picture, and that definition written down. You can simplify my definition if you want to, but that's a pretty good one. All right, so All right, so now I said we talk about supplementary. Supplementary angle, or these are two angles that equal 180 degrees. Okay, so they have to be touching. So remember, when we talk about that straight line, somebody might say, well, that's a 0 degrees. Well, if we're measuring that whole thing, that's 180. So we're measuring this arc, this angle, that's 180 degrees. If we cut that, so here we've cut that 180 degrees with a line, and now we have one angle is 120, and that means that the other angle is 60, because 120 plus 60, you're right, that equals 180. Make sure you have supplementary angles copied in your notebook. Go ahead and pause me and go from there. All right, so let's take a look at this example. So now we're going to try to find out the measures of angles 1 and angle 2. We have this measurement here. So pause the video, see what you can do. I've got answers on the next screen. All right, so angle 1, okay, angle 1 is the corresponding angle to the 90-degree angle. So 1 is also 99 degrees. If 1 is 99 degrees, 2 is supplementary to angle 1. Supplementary, remember, supplementary angles equal 180 degrees. So if they're supplementary, then angle 1 plus angle 2 is equal to 180 degrees. And 99 plus angle 2 is equal to 180 degrees. We're going to subtract that 99 from each side. And that leaves us with, guess what? Angle 2 is equal to 81 degrees. That's kind of really cool. So the measure of angle 2 is 81 degrees. And we know that because 1 is corresponding to the 99 and 1 and 2 are supplementary, so they have to equal 180 degrees. That is so cool. I hope you're enjoying that too. I think it's, I really do. I think it's very neat. All right. My next example. So we're going to use this figure to find the measures of angles 1 and 2 and explain your reasoning. So what I want you to do here again is pause, see if you can figure out what angle 1 is and angle 2. I've got answers on the next slide. All right, so let's take a look at your answers. So you're right. Angle 1 is corresponding. It corresponds to 63 degrees. So angle 1 is 63 degrees. And that means that angle 2 is the supplementary angle to 1. Okay, so that has to equal 180 together. So 63 and 117, they equal 180 degrees. Again, I just find that to be super cool. All right, let's go on. So now I want to take a minute for you to add this to your notebook. So go ahead and pause. But vertical angles are a pair of angles that are just opposite angles by the intersecting lines. So X and X there in the purple, those are vertical angles, and Y, those are vertical angles. That means that their angle is the same. And you can see that the vertical angle theorem explains just that. So put that in your notebook. Make sure you're putting the words and the drawing in there. All right, the other term I want to talk about right now is congruent. And I said that I'd have a slide on this earlier, so here it is. Congruent angles have the same angle. Now these angles here, they're the same angle, but note that this guy has longer lines. It does not change the angle. See there, it's the same. This one has longer lines than this one, but the angle is exactly the same, and I can show you that again. Isn't that cool? So the angle is the same. It's 45. All right. I worked really hard on that. I hope you like that. So anyway, the congruent angles, same angle. Okay. So now with what you've learned, I want you to add that drawing right there. I bet you got this figured out. I'm going to have answers on the next slide, and we're going to figure out all of the angles now. So we're going to figure out angle 1 through 7 there, because we have one of the 8. All right. So here we go. I hope you figured them out. I hope you took some time to do that. It's not just me telling you. So we've got that first one that's labeled in the red there with 75 degrees. Now 1 is a vertical angle to that. So they're congruent. They're the same. So 1 is 75. Now that means that angle 2, and angle 1 have to equal, you got it, they have to equal 180 degrees. So if that is true,